Hello everyone. So this is another AMC12A problem. So this was, I guess, number 22. So we have circles, actual two circles, like circles 1 and 2, each have a radius of 1, which is like this one is the circle 1, and then this one is the circle 2. And this between these centers is given as 1/2. So this is center of the circle 1. And this is the center of the circle 2 that is given 1/2. And there is another circle 3 that is internal tangent to both of these circle 1 and 2. So this is the largest circle that you can draw inside of those two circles that is tangent internally. Okay, so that is the another circle. And we are given one more circle that is actually the circle that you can draw in between the circle like 3, outside of circle 3, a tangent in circle 3, inside of the circle 2 and circle 1. So I hope that makes sense so far. So that is what we are given. Based on this, what we are looking for the radius of the smallest circle. So usually whenever you are dealing with some sort of distances, length in circles, it's really nice to find their centers and connect them some common intersections, which usually guide you some better approaches. So which is why I will go ahead and label the center of the C4, which is what we are looking for. And this is the center of C1, this is the center of C2. And right in the middle, since those C1 and C2 is identical, right in the middle will be center of the C3. So which is why this guy will be 1/4 and this guy will be 1/4 as well. So let's connect the center of the C4 to center of the C3. So since they are in tangent at this point, so when you connect the centers, it will make a straight line going through that tangent point. Okay, so that is something. And also this angle right here has to be 90 degrees. Okay, so that is another thing we have. And what also like we need to know is just the radius of the C3, right? Which is we don't know yet. But if you were to kind of draw this a bit. Okay, so to make a radius of the C3, since this is the center. So we know that the radius of the C1 and C2 was 1. So the distance between like this point, okay, to this point is the radius is 1. And the same idea, distance between this point to this point, because this is also still on the circle 1. So this point is this is the center of the circle 1. This is a point on the circle 1. So which means the distance between this point to this point is 1 unit. Since we know this is 1/2, so meaning that the rest should be 1/2 as well. Okay, so this is 1/2, this is 1/4. So this point was the center of the circle 3. If you connect this to this, so this is add up to the center of the circle 3. So radius of circle 3 is basically 1/2 and 1/4, which is 3/4. So which is the same as right here. So that is also radius of the C3, and that is what we have. I'm gonna call the radius of the C4 is just R. Pythagorean is one of the best friends, I guess. So if you connect the like center to this center, so let's see what we are gonna have. So we are gonna do this point to this point. So if I do this, I will get a right triangle, but I don't really know this segment. So if I know this segment in terms of at least R, then I could get something nicer. So, but this is also possible because if you just imagine the segment from this point to all the way to the tangency point of C1 and C4, that will make a straight line, right? So, and then that is the red line that I just draw is 1 because that's the radius of the C1. So let me draw this a bit larger so we can kind of see what's going on. So it is something like this. So we have a right triangle. And I do have something like that. So I just did this extra point. So if I take this intersection, let's say K, so this is K. The distance between the center of the C4 to K, I'm gonna call that R. That's my question. And since we know this is the, let's say O, the center of C1, from O to K is 1 unit. So that means this piece will be 1 minus R. That is equal. Okay, so as soon as we have this guy, and we are gonna just find the other leg. So you know this one was 1/4, so that is 1/4. And I like to know this segment in terms of R, so I can use the Pythagorean, which is possible because this point to this point is my radius of the C3, so which is 3/4. And then this part is radius of the smallest like C4 circle. So which is why this is gonna be actually R plus 3/4. So now we can use the Pythagorean. So let's go ahead and do that. And if I use the Pythagorean, you know, that should be 1/4 squared plus R plus 3/4 square is equal to 1 minus R squared. So if you expand those, so you will get 1/16. And that should be R squared. If you square, like use the binomial, square our binomial, or you just multiply this twice and multiply. And that should give us 2 times these two numbers, which is 3/2R plus 9/16. And that is my 1 minus 2R plus R squared. So I use the square of binomial to expand this, which is useful. And which is really nicer since we have R squares will cancel conveniently. So we got those out of the way. And then 9/16, 1/16 is 10/16, which is 5/8, right? So, and then I have 3/2 R is equal to 1 minus 2R. So if you add 2R to both sides, so you will get 4R/2, which is 7R over 2, 7/2R. And if you subtract 5/8 from both sides, you will get 3/8. And do cross multiplication, so the R should be 56 divided by 6, cancel 2s, that will be 28. Actually, no. Actually, yeah, that would be 3/20. Okay, so, and then that is my final answer. So I hope that was clear. So this was one of the challenging questions. So I'll see you in the next video.